Today, ISDC here in Cleveland, we're glad to welcome Dana Andrews from the Boeing Space Systems Group in Seattle, Washington. He's been the chief engineer for the joint project RLTV for the McDonnell Douglas and Boeing systems, and he's ran the Boeing commercial space transportation project for Boeing that he's going to be speaking about today. Other programs include the BMDO study and the habitat module for the space station. If we could all welcome Dana Andrews.
Thank you. I'm here representing Boeing, obviously, but I'm speaking for the group that did the commercial space transportation study. That was a study done in '93 and '94. It was done by all 6 of your major aerospace companies, who are now, I guess, down to 4. That would be General Dynamics, Boeing, Lockheed, Martin, Rockwell. Forgot anybody? Anyway, what we did is David Webb talked about it earlier, Dr. Webb, that in '93 time period, we looked at what was happening in all the launches going overseas. And we said, hey, we're going to have to do something. Will the market justify a leapfrog system, was the bottom line. We got together with NASA. We actually gave a briefing to Golden, where we said, look, if we're willing to put money up, if you're willing to put money up, let's look to see if the future market will justify a leapfrog system, in which case we'll put a plan together where we will do it commercially. And that was Dan Golden jumped the chance, and this study was born. Give me the next slide. The whole thing was, as I said, everyone has said, and I heard it at least twice today, is if space transportation costs were dramatically reduced, we get this great expansion in the market. And our purpose was, okay, we want to expand the space market. We're in that business. How elastic is that market, and will it justify a totally commercial endeavor now, in the near-term future? We've lost 400,000 jobs in this industry. We have, the gentleman this morning talked about, today was a red letter day for NASA. Well, today's pink slip day at Boeing, okay? 7,000 people got pink slips, and today's the day they go out the door. So we very much understand what's going on in the industry, and we want space as bad as you guys do because of the jobs involved. Next one. The classic approach in doing a market study like this is you've got a vehicle and you want to sell it. So you go out and try to sell your vehicle. You survey the market, you try to sell your concept. What we did in this study is we don't have a vehicle. We're 6 different companies. We're going to survey the market. We're going to create the market. If the market's not there, we're going to see if we can pull some people in. People who don't know they're going to be launching spacecraft in 10 years right now, and get them, you might say, a little bit pregnant with the idea of working in space. By now you've read the chart, so let's go on to the next one. It was a 4-part study. The first part is the only part that was actually ever done. The first part was to explore the market, to go out and survey the users, and find out where we could identify users, where we could identify market and identify the traffic. And basically it's the square there. Is there a credible, sustainable market in space in the near term, within the next 10 years? The second phase was going to be, and after each phase there's an off-ramp. NASA was putting up about 2/3 of the money. We were putting up about 1/3 of our own money. And actually we probably put quite a bit more than 1/3 when all was said and done. If there was a credible market, then we go to the second phase, is can we design a vehicle to meet the requirements to satisfy that market? Can we really get an order of magnitude or 2 orders of magnitude down in cost to capture the market? The third phase then, and that was going to be 50-50 between industry and NASA when we fund phase 2. Phase 3 was, okay, we got to develop some technology. If we find a vehicle we're sure, and now that we're in the middle of RLV, we're doubly sure, it's going to require some new technologies. So develop the technology, demonstrate the technology to get the risks down. See, are the business risks acceptable to go to phase 4? Phase 3 was going to be largely on NASA. I mean, that's NASA's job, research and technology. Phase 4 is there a sufficient committed market, and go for it. And that's develop the system. That was going to be on us. And by on us, we're talking about a consortium of the 6 major aerospace industries. That was the plan. Now what happened was, is we did the market study, which I'm going to show you in a minute or two, and we found out that there wasn't a true commercial, strictly commercial play. We couldn't, the return on the investment was totally inadequate to go ahead commercially. At that point, NASA opted out, essentially, and started the RLV program, which is a quasi-commercial development right now. Next slide, please. We looked at what we think, I think we covered the waterfront. If you have another couple of markets that were unidentified or not on that list, come see me. We tried to look at everything, and some were existing markets, and some were markets with a rather high giggle factor that was sometimes hard to explain to our management why we were spending their money looking at them. But we tried to look at everything. We went out, we put together a market survey. We went out 2 by 2 and interviewed everybody in the market, literally. We spent hundreds of thousands of dollars on travel, on phone bills, and went out, contacted, put together business plans for where we identified a viable market. We put together business plans and came back with the people and showed them a business plan how they could make money. The idea is they had to make money. This is the way we do things commercially, is you help your customer make money, and therefore he buys your product. So that was what we were doing. It was showing people everywhere from medical supply houses to manufacturing houses how they could make money in space. And all that got published in this is the executive summary, but there's a rather large compendium which we produced about 400 copies, and they're out there somewhere. I'm sure some of you have some of them. That reviews the results of those trades and what we found out. Next one, please. We sorted them into their probability of happening. If there was potential commercial customer interest, that means they made at least a low probability market. If beyond potential customer interest, if there was a favorable business outlook, looks like that you could indeed get someone interested in doing something there, that was the second step. If there was the market could some more, in other words, if you could show a 20% return on investment in that market, then it became a high probability market at whatever launch cost we're looking at. And we did this as a function of cost per pound to orbit. The idea being is we wanted to find where the market became elastic, where it took off, to where, and that's the market we wanted to seek. Next slide, please. If you plot the launch, this is the total pounds in orbit in 1 year as a function of launch cost and as a function of probability of the market. I'll get into some what these markets are a little later. But usually these markets are built up. We may identify 20 different types of missions, total market, 20 pieces of the total market. But this is the total market plot. High probability is a 90% probability that if we could beat that launch cost, that market would go. Medium probability is 50-50. And this is, again, it's a function of how many people are interested, are they funded, do they have the wherewithal to go ahead, and does the business outlook, does the business plan say, yeah, you can make money at it? Then a low probability is there's somebody interested, but we can't see a way to make a profit. And interestingly enough, when we did the study, teledesic was in the low probability market. They weren't teledesic then. Now I think I'd be forced to shift them at least into the medium. But this, and what you see here is that you see that things grow rather slowly when you leave. And if you're in the 10 to 5,000 pound range, that's where we are today. About 1,100, 1.1 million pounds to orbit. So about what we do today. Once you get down, you start down below that, you get a very slow increase. And what you find, the reason for that is that the big launchers today have to do with the military and have to do with the commercial folks. And if you go look at their costs, launch cost is not a major factor. You know, their total life cycle cost, launch costs are 20% or less. So you can have their launch cost, and they're going to say, so what? That's not a major player in their overall economics. So nothing much happens till you get to the new markets, and that's you get down below $1,000 a pound, you get down in the $500 a pound range. Then we start to see in totally new markets that don't exist today. And I'll get into some of those next. Now just a second, Chuck, before you leave that chart, I'm not going to cover all the ranges. I'm going to talk medium market probability today. So I want you to look at the high probability market is about a third, roughly a third of the medium probability, and the medium probability is roughly a third of the high probability. Because we're gonna show some costs later on. You got to remember that factor of 3. Go. When you multiply the market at a certain dollars per pound times the dollars per pound, you get this plot, which is rather discouraging. And it says as you decrease the launch costs, even though the mass you launch goes up, your total revenue goes down. Until you get way down here into the $400 or $500 a pound range. Now what that says is that right now all the launchers are sitting on the peak profitability point. Does that surprise you?
No.
And until we get what we have in the airline business, which is called predatory pricing, okay, we're not going to get off that $4,000 a pound range, because that's where you maximize your profit. So what it says is we're going to have to do a leapfrog system and force things down into to the next profit bucket. And it means is that gradual improvements in the system, okay, aren't going to drive you down in the $500 a pound range. So if you've got a commercial system and you want to get rich, you're going to have to do the leapfrog system, or you're going to have to drive your neighbors out of business. That's what it boils down to. Next. If you look at where those markets are, and then now you start at $1,000 a pound, which is 1/5 of current prices. Okay, we go from 1.1 million pounds to 1.9 million pounds, and indeed, what you see is that the government and commercial dominates. The communications, I'm sorry, what I should say is communications dominates. And this is medium probability, so it doesn't include things like teledesic when we did the study. You see, the government is still a major player, 28%. And this is where this is the near future, guys. If we continue to make better expendables, this is what you'll see. Still dominated by communications, and the government's still a major player. Now, if we can do a leapfrog system and get down into the $600 a pound range, which is the threshold of the new market type work, what we see is, well, we just tripled in size. We're up to 4.5 million pounds. And we see something huge there called hazardous wastes. And what that is space disposal of nuclear waste, which is one of the high gig factor. And I'll get into it a little later, and you'll find out that it's not quite so silly. And that's why it's up there, is there is definitely a market there, but it's tied up in political baggage, okay, that may make it unsurmountable, even though it's a valid market. The second new market there is business park, and I'll get into business. Business park is probably the greatest new play that we ran across. If you drop it down to $400 a pound, you see it expands again largely. And what happened is that you got a great growth in some of the lunar missions and a big jump in the business park. The business park became way more profitable and started to multiply. Now, we did not go below $100 a pound, and that was just based on physics as we know it. The rocket engines, we had a little clip with Jerry Purnell earlier in one of the other sessions talking about how we should be able to launch for 3 times the cost of propellant. Yes, if we were an airline, I agree with that. However, is a single-staged orbit. We have exotic new alloys. We have very high-strung rocket engines because we need them to make a single-staged orbit get to orbit. So we can't see any way to get there next generation. Second generation, let's go for $50 a pound. But what we know how to build now in the next 3 or 4 years, we're not going to get that low. And that's, anybody that tells you different hasn't been in the trenches trying to design these things in detail. Next one. The Space Business Park, I said I'd get into some of the examples. The Space Business Park is essentially taking modules that were designed by government, actually by Boeing. I was there, I know what they look like. And buying them commercially and putting up a business park. This will be done after the space station flies, because in the commercial business, we're not big risk takers. Okay, we want to use something we know works. And after space station flies, we will know that the solar panels and the airlocks and the modules all work, the ventilation works, the plumbing works. Nothing worse than the space station when the plumbing doesn't work. So we would take those components and launch them on our low-cost launcher and build a sort of a commercial business park, is what it is. We would actually accept passengers, and we use them as packing between the crates, in effect. You don't make much money at these costs per flight on passengers. So they fit in between the racks. They're good, like I said, good packing. They do add a few percent to your profit margin, so they're worth going after. But basically, you're hauling up pharmaceuticals for processing. We're going to process, probably build some organs for transplants. There's a number of things we can do with modern electronics, and the secret to making this work is regularly scheduled flights. The fact that you can call up and fly on the Friday rocket 3 weeks from now. They got a rack available. The idea is you go up and you go down on schedule, and you don't have to go through 2 years of paperwork to fly on the space shuttle. That's the secret. And we went out and talked to the people who are currently doing materials processing in space and found out, well, how come this is not a big market? And they explained it to us, because we got to deal with NASA. Okay, and all you NASA people out there, I apologize, but that's what they said. We had people tell us horror stories of having to do outgassing tests on aluminum fittings. They had to actually put them in a vacuum chamber and show they didn't outgas. Just all kinds of things that just boggles the mind. And it's because the space shuttle is a very expensive thing. We don't want to lose it, and it's manned. And those are the reasons why it costs so much to get something on the shuttle. If you're doing this on a regular commercial basis, the permits to fly in the belly of a 757 cross country to ship your freight in there is literally, you have to sign a piece of paper that says it won't blow up. Okay, that's the requirements. Well, that's the type of requirements we want to see for a facility like this. Next one. If you look at what people would buy for lockers, what we did is went through what's currently flying and interviewed these guys to find out where their cost threshold was. What were their budgets? How much could they afford to divert initially and later on to doing the research they're doing now on the ground in space, and come up with these curves, which are the 10% probability line is the top one. I guess these are set up right. One of these charts has them reversed, and the lowest probability is down at the bottom. Now, what we actually did is put the medium probability down and then factored things from that. So the medium probability is the one I have a lot of confidence in. The other two are sort of, okay, well, let's ban this. But now you see that at $100,000 a rack for a week, okay, we're talking roughly 3,000 racks going up for a year. Now what we're going to do then is we're going to run the economics on that. Next one. I think the next one's tourists. This is high-end tourism. High-end tourism is, these are the people that fly on this are the people that normally spend about $25,000 a month on their AMX, using their AMX, okay? And believe me, the companies know who those people are, and they know exactly what their spending habits are. So we can talk to the high-end travel people and they can confirm all these numbers as to how many people are going to fly at the high end. Now obviously as you get down to the low end, you get to the $10,000 a pound, we're a little short of the million people a year at $10,000 a ticket. Okay, and we know that. We were conservative. And that's because we're spending our own money and we're going after a commercial venture to our management, our upper management. And if they see one hole in your numbers, if they think you were at least bit optimistic someplace, you lose your credibility across the entire spectrum. So we were conservative and we know it. And I won't apologize for it. But I think you're going to find out it doesn't make that big a difference. Okay, let's go. What you find out on the economics of the business part, the reason it doesn't make any difference is the tourism market, even then, at those prices, is only a couple $100 million a year in total revenue. And that's, you know, that's not worth chasing. Not when you're costing you $10 billion to develop the system. This is the space business part with the tourism. We call the tourism part of it the B&B, the bed and breakfast. They're up for a week. They got a stateroom with a great view. And we might even take them outdoors for a little expedition. But it's basically a B&B. It's a working station. It's not catering to tourists. And the travel people tell us that it's not going to be a problem. Okay, it costs you thousands of dollars to go on archaeology digs now, and all you do is work in the sun all day and get terribly dusty. Okay, we'll do better than that. But what we find out is in the low probability market, you can start making money about $1,000 a pound. This is, again, 90% of the profit is in the materials processing, not in the tourism. At the medium probability, you start making money a little below $600 a pound. And you see it is highly elastic. As the cost goes down, you see the cost goes down by a factor of 3. We get over an order of magnitude increase in traffic. So we are in the elastic regime. So if we can get our costs down in the $200 to $100 range, it will pay. Next. The phasing on this is basically, let's do the station. Once the space station's up there and is apparent is successful, then let's get serious about a space business park. That's the overall plan. As I say, it looks like based on the schedule of the space station, we'd probably have our launch system up and proven. If you're going to carry passengers, okay, and it was discussed today, you're going to have at least 4 nines of reliability. At least 4 nines. You fly in commercial airplanes right now, they have roughly 8 nines of reliability. And it will not do our space park any good if we lose a vehicle full of tourists right up front. So you're not going to fly tourists #1 flight. You're going to get several hundred flights under your belt, demonstrate your reliability, and then you'll start carrying tourists. And as the demand increase, you just replicate the business parks. I can see someday real estate in low Earth orbit selling like real estate on Earth. In other words, you'll have an altitude and an ascension node that you own. Okay, that's yours, and it will be passed down from generation to generation. That's someday. The other near-term market that we need to really develop this new market is space disposal of nuclear waste. Now, you may or may not know that, but in approximately, well, about the time we turn off the last nuclear power plant in this country, which is predictable since we haven't built one in quite a while, we'll have 50,000 tons of high-level waste. You add that another 5,000 tons of weapons-grade plutonium we're buying from the Russians and demanning our warheads. We have a lot of stuff that we don't really want sitting around. So what we could do, offer them is, and right now, that 50,000 tons of waste is sitting in cooling ponds in commercial reactors, and they want nothing to do with it. Now, the government offered several years ago to take it off their hands in 1998 and put it in a permanent repository. Well, the permanent repository in Yucca Mountain is not quite politically dead, but yes, is equivalent to being dead, I guess. It's a political non-entity right now. So We have these guys sitting with all this lovely nuclear waste in the backyard of their nuclear power plant, and we're going to start having to shut the plants down because local communities are not giving them permission to expand their cooling plants, their cooling pools. So we have a problem that it's approaching at 1 year per year here, and we're doing nothing about it. What we could do is, it turns out the stuff is not garbage. There's all kinds of very valuable isotopes there. The problem is, nobody will let you process it, because what are you going to do with the drudge? The stuff that is hot is nasty shit, and you got to do something with it. So no one will process it. If we offer a way to get rid of it, permanent, well, not permanent, nothing's permanent. First ground rule, nothing's permanent. If we offer to get rid of it for a long, long, long time, okay, then they could go ahead and process. And what we aim to do is, we collect it, bring it to a central agency, strip off the cladding, compact and bury it, because it's about as radioactive as ore, chemically dissolve the uranium oxides out and recycle them back into the nuclear power industry, process out the viable isotopes, and then load it into these, the GPHS, essentially what we use to launch RTGs in space, and store it for about 10 years until we demonstrate high reliability in our lock-in system. And no one minds having it there for 10 years. It's the 20,000 years they worry about. Then we transfer it to a facility and ship it into space. And when I mean ship it into space, I mean we soft landed in a crater in the backside of the moon. Now, we looked at all different places to put it. It's too expensive to launch it into the sun. If we put it in orbit around the Earth or around the sun, these are alpha and gamma ray emitters, and we now do a lot of telescope work in those frequencies. And there'd be all these little spots out there, you didn't know if they were close, if they were 100 light years away. So the astronomers would get a little upset. Plus, there's now A10 asteroids, which we didn't know about when we did these studies 10 years ago. Which means there's stuff circulating inside Earth, between the Earth and the sun. So we don't want to put this any place where something might deflect it and send it back to us, because this is nasty stuff. So if we soft land it in a crater in the backside of the moon, we know exactly where it is. If it comes back, that's the least of our problems. Okay? And we can go get it if we need to. In other words, if we find another use for them, some of the stuff, we just go get it. And there aren't going to be too many terrorists with a big enough budget to go get all that plutonium anyway. So it works. Now the biggest factor, next one please. The biggest factor there is there is a budget there, okay? They're currently charging everybody 1/10 of a cent per kilowatt hour for nuclear generated electricity. So there's a slush fund there of about $1.8 billion per year. Now couldn't we find a good use for $1.8 billion continuously over the next 30 years? I think we could put it to good use. If you look at the current DOE cost, what it's going to cost essentially over the next thousands of years in upfront cost, they're predicting $43 billion to protect it at Yucca Mountain. We look at what we'd have to launch it for, and we find out that, and the ground processing costs, I'm sorry they're in dollars per kilogram, but that's the way the processors look at it. Right now, we're probably somewhere between $0 and $100 a kilogram. In other words, we've identified enough good uses for the isotopes that the cost of processing is almost entirely taken up by sales of the isotope. So essentially, the isotope people will pay us to take it off their hands. So we find out between $400 and $600 a pound. Okay, we reach break even with what the government plans to spend already, which says that's a viable market if we can handle it politically, and that's the big question. Go ahead. Now I'm going to get into the economics of the overall scheme of things. What we did is we identified these markets: high probability, which is low, essentially low mass, medium probability, and low probability, which is the greatest launch rate but the lowest probability of actually happening. We then segmented that by payload size and type so we could look at different vehicle sizes and identify them in relationship to the market and find out what part of that market is actually capturable. What part will we actually fly and at what size? We looked at 10,000 pound, 30,000 pound, 55,000 pound, and 100,000 pound capability launch vehicles. Now, we didn't actually do launch vehicles. We had a standing rule in this program. The first guy that showed a vehicle had his leg broken. And we never, the entire program, nobody ever showed a picture of a vehicle. Go ahead. This is, this is medium probability market. What you can do is if you want to look at the high probability market, you divide all these numbers by 3. If you want to look at the low probability market, you multiply them by 3. It's a ground rule to remember. And so what you find out is that at current dollars per pound, you know, you can see the 30 to 40 launches that are currently happening in those sizes. And what you find out is what we capture is a very small part of that. Because if we entered the market now, we're the new kid on the block. Now, why would, if you were Hughes, why would you run over and fly on us if we were the same price? Because we're an unproven system. So we don't capture much. But when we drop our price, now we start to capture an appreciable part of the market. We drop down to $1,000 a pound. Now we're looking at capture rates, depending on the size of the vehicle, you know, we'll fly anywhere from, say, 20 to 50 times a year. At $600 a pound, we introduce new markets now. And now we're below everybody else, and we're capturing almost everything. So you see that we're flying the order of 80 times a year. You get down to $400 a pound, now you see the growth is starting. We're starting to get to the elastic, where if you drop the cost, the market does increase now. And now we're talking, you know, 200 flights a year at the small sizes. Next one. So what you do then is you look at these capture rates. Now we have payload size along the x-axis. Along the y-axis, we've got dollars per pound to orbit, and we've got annual revenue plotted on the z-axis. And you see now, well, where do you want to be? Well, obviously, you want to be around $600 a pound, somewhere around 30 to 5,500, 55,000 pounds a flight. So we're talking the order of $2 billion of revenue. Again, remember that number. That says medium probability, 50% probability is roughly $2 billion a year in total gross revenue. If you go with the high probability, the one that our financial people tend to believe, it's a third of that. If you're optimistic and say, hey, this market will grow, and what it really tells us is we've got to go out and help the market grow. We've got to help make that low model real. Then you get 3 times that, and you're up around $6 billion. Next one. What you find out is that the cost of capital is what is the real problem here. Assuming $5 billion in total investment, and I could build you an SSTO for I can do the prototype for $5 billion, I guarantee it. But I may not be able to buy the fleet, and I probably wouldn't be able to buy the infrastructure for that. So it's probably going to cost more than that. But let's just assume $5 billion. If I'm Boeing, or if I'm McModel Douglas, or if I'm Martin, and I go talk to my corporate guys that wear the green eye shades, and they're going to say, don't come see me unless you can show me a 20% internal rate of return on this investment. 20% internal rate of return means is I'm getting, after 10 years, I can show a 20% annualized rate of return, ignoring taxes and interest and all that. This is just internal rate of return. And that's sort of the bottom line for an investment of this magnitude is I'll go build a new airplane, or I'll go build refrigerators if you're under 20%, because I know I can make better money there. And this is life in the real world, guys. Okay? You have to show that this is an investment worth doing. And what you see then is as a function of, say, 20% IRR, I have to return a certain amount of profit per flight to pay off to get to that 20% IRR. And if I fly 100 times a year, that amount of money is about $25 million per flight that I have to show in profit. Well, I think those of you, I see faces lighting up, have done the arithmetic. How am I going to get down to $100 a pound if I've got to have $25 million of profit out of the price? You can't. You can't get there from here. And that's the problem, is that the profit to service even a $5 billion investment drives my cost to the point where I can't offer those really cheap rides because I've got to show a profit on these flights. Next one. This just shows you kind of what for a $5 billion, this is the same chart replotted, for a $5 billion investment, 20% IRR, okay, that says I need $2.4 million free cash flow. Remember, my gross revenue was $2.4 billion. Okay, so I have to operate for nothing to be able to pull this off. And I don't know many systems you can operate for no cost. So what it says is to service this, to assume that half of that 2.4 is profit and half is operating costs, which is optimistic, really. Okay, that says that I can only service, I can afford to spend about $2.5 to $3 billion and come out ahead. The underlying problem here is the total market. You know, Boeing, and it was mentioned earlier, Boeing invested somewhere between under $10 billion, well, over 5 and less than 10, let's play, for this 777. But we had 144 confirmed orders and a bunch more we don't talk about. Okay, I go ahead with this system and my total net sales is probably 3. Okay, because that services the entire market. Now, what is my board going to think when I come up to them and say, yeah, I want to do the 777 over again, and I've got 3 confirmed sales, and that's probably all they'll ever have, because that satisfies the market for the next 20 years. No sell. That's why the government, despite what we'd like, is going to be a player here. Okay, it's just like, you know, we didn't develop commercial airlines way back when totally, commercially. You know, the government helped. The railroad, transcontinental railroads, the government helped. Well, we're there again, guys. I don't see any way to get there from here without somebody helping up front. Now, the users of this vehicle make out like bandits. You know, we can see $8–10 billion a year in revenue if the vehicles were available. But it's the idiot that builds the vehicles that takes it in the shorts. And right now, I don't see any way around that. Conclusions. I see a lot of solemn faces out there. I'm sorry for this. We see little or no growth in the government markets, and I didn't have time really to cover everything there, so I sort of skipped over that. But the government markets, they're essentially limited by funding. Okay, and you drop the launch cost, and chances are they're not going to be able to do anything else because their budgets include, most of their budget is going to build the things that get launched, not do the launch vehicles themselves. So any meaningful growth will be dependent on commercial space development. Indeed, that looks good. If we can get that cost down, that market does become elastic, and there is profit to be made there. The 4 market areas of prime interest here are communications and government missions. Those are the near term. Those are the existing markets. They won't grow much, but they're like money in the bank because they do provide revenue. The 2 new ones that need to be pushed, we need maybe some activist help there, is seriously looking at nuclear waste disposal and seriously looking at the business park. Because those look like totally new markets and they look like growth markets. Go ahead. The price threshold is between $600 and $400 a pound. And the vehicles in the 30 to 55,000 pound due east Leo are about the right size. And indeed, that's where we're looking in ROV, in the same general range. The new launch vehicle, which serves the medium probability market, and remember, I'm only talking medium, all this is said for medium probability. If you can make the low probability market real, things get better. But you're going to have to do some work to convince people those low probability missions are real. You're going to have to sell tickets there somehow. Okay, we're talking for the launch people who I represent, roughly $2 billion in revenue for the operator of the system. That's equivalent to about 20,000 aerospace jobs, about 5 times that in national jobs, and about $500 million in overseas positive balance of trade. Our business assessment, however, is hey, the high probability market does not support a commercial business venture at all. The medium probability market must materialize to even think about it, and there it's an extremely long shot. We need, you know, someone's got to do some additional work to bring more people into the fold, and that's where you guys come in. And the business risks remain high. Anytime you're talking about pushing technology this hard for this little return, guys, again, I'm talking as a manufacturer of launch vehicles, it's a problem. Now, if you want to know, this is the commercial version. This is all 6 companies. If you want to know what we think at Boeing, and that's why I threw one chart in to say that, we feel proud of the CSDS study. Okay, it was the first cooperative effort of all 6 companies in a long, long time. We got together well. We did a lot of work, and we think we did some good work. We think the space market's poised for expansion. If we can get a launch system, if the conditions are right, if there's that low-cost launch system there, we think the space market will go, and I think you probably agree with that. Significant expansion requires airline-like service and standards, and indeed, on the team I'm on, that's what we're shooting for. That's where we're headed in RLV, is airplane-like service and standards. Unfortunately, that's going to cost a little more because you've got to do a better job. And I think it goes without saying, if you're going to industrialize space, if you're going to get beyond communications and government satellites, you're going to have to get down into that $500 or less range. And the only way to do that is with a leapfrog system. And unfortunately, the predicted traffic rate that we can see right now does not provide the developer operator with an ROI commensurate with the risk right now. And that's why the government probably has a place to play. If we're going to open that space market, it's going to require some cooperation amongst all parties interested. The aerospace industry and the activists need to simulate future users. We need to get more people talking, more people telling their congressmen they see a way to make money in space. That's a problem right now. We went out and talked to guys, and they say, "Where have you been? You used to come see us all the time, and then Challenger happened, and we haven't seen you since." And that's an onus on us. Okay, after Challenger, we sort of gave up on commercialization of space as far as the aerospace industry went. And so that's our baggage. We've got to do better. The government needs to implement the technology base. You cannot do an SSTO with existing technology, not one that's going to hang together for more than 1 or 2 flights. So the government has a place to play there because we can't afford to do that all on our own. It's too big a leap. And then the government, the industry, and bankers, and everybody else needs to find a way to finance this because right now it doesn't make sense from a truly commercial play. And that's all I have to say. Any questions?
Sorry, do these figures represent international or just U.S. market potentially?
This represents international.
Okay.
Yes.
Do any of the DCX, the X-34, any of these look promising towards that, or are we still groping around in the dark?
No. I think both the X-34 and the X-33 are headed in the right direction. I think they're doing the things that need to be done. Remember, in industry, we're risk averse when we're talking billions of dollars. When you bet your company, okay, you want to understand all the pitfalls you're facing and have a way around them. And I think the X-34 and the X-33 are aimed at helping us get rid of some of those pitfalls. Yes?
In one of your earlier foils, it showed, I don't remember exactly what was on the vertical axis, the horizontal was dollars per pound, and about the $10,000 per pound it was sort of high, then went down gradually, and then there was a spike around 500 and then went down again.
That was gross revenue.
Gross revenue, okay. What was happening with that spike? Why was it so narrow as compared with the other profitability range below it?
What happens is that you introduce a new market starts. What happens is if you're not creating a new market, that you will improve. They will fly more of an existing vehicle. They'll put up more satellites if it's cheaper, but not many more. I mean, how many channels of TV do you really need? And so what happens is that the total flights are going up, the number of flights are going up, but your revenue is dropping faster. Now you introduce a new market, and those are big markets. I mean, we're talking the space park. The first space park fly once a week. So that's another 50 launches, bang, all of a sudden it happens. And that's why you see this jump. Well, what happens is if we continued below $100 a pound, you would see two big spikes take off, solar power and tourism. Okay, solar power happens right around $50 a pound, okay? It's affordable to put satellites up there and generate power. And at about $10 a pound, tourism becomes profitable. Yes?
Going back to, you mentioned solar power satellites, are you considering the NASA baseline or some of the possible new stuff, like the Lightman solar power satellite?
I've actually got some foils in there. If we had time, I guess I could cover them. We looked at three different classes. One was the classic NASA GEO satellite, deliver base power. One was a sun-synchronous satellite that delivers, it was in a 6 a.m. and 6 p.m. orbit, and it delivered peak power. Because peak power you sell in this country for about 9 cents a kilowatt hour. In parts of Europe and Asia, peak power goes for 30 cents a kilowatt hour. Then the last one was a Molniya orbit satellite, okay, which went after specific markets, Japan and the middle Europe. Okay, in Japan right now, peak power is about 23 cents a kilowatt hour. And so you can afford, so we went after specific markets in the world. So we looked at three different classes of solar satellites, and they all became profitable right around $50 a pound.
Launching all terrestrial.
Yeah, yes, this was not, no lunar materials. Yes?
You said that when you get to a certain point, the $600, $4 million range, your users are making piles of money, and the people that like Boeing ended up getting caught.
That's because we couldn't sell enough vehicles.
Right.
These are very efficient vehicles. Chances are you'll be able to turn them around in less than a day. So if you've got a fleet of 4 or 5, you cover the market. And you handle the market. That's why I talked earlier about, that's all we need now is 2 competitors. Okay, going after a total market of 4 vehicles.
So if you could come up with a business structure that took advantage of, say, getting a percentage of the cut, what happens then?
The antitrust laws will get you.
We did that once before, if you remember. United Airlines and Pratt & Whitney used to be part of the Boeing Corporation.
You're saying the antitrust law?
It's hard to say what will happen in space. I mean, I'm not sure which laws apply at all. But I would expect us to be some of the operators, but a lot of this is going to be places where the aerospace industry has no expertise. I mean, we don't normally operate hotels. So you can't imagine that we're going to do that. I can't imagine we'd do it well. Yes?
Dana, that chart shows that your revenue is dropping. I can see that it's peaking about 400. Is that
Yeah.
right? 400 per pound. And you're saying profitability for tourism is $50 a pound. Based on that chart, no one would do it. No one would make the vehicles because you're saying you'd only make a few. So the launcher, the launch craft builder would not make enough
Well,
money.
that's the bottom line, is we can't see a way, and that's why the CSDS study ended at phase 1, is that we could not see a straight commercial play here. Now, if we limit our investment in the $2 to $3 million range, okay, then we can come out, we get our money back and enough profit to interest the corporation in making the investment. That's what it boils down to.
So these vehicles, when you assume space tourism, were you assuming buses as opposed to private cars or something?
We did not go below $100 a pound because we were trying to look for a near, like I said, that's second generation, and we're wrestling with first generation right now. We just couldn't see how to get there from here. Yes?
Can you make it go with the nuclear waste stuff? That's the first part of the question. The second part is, how do we as activists alert the folks to this timeline?
I think we need to get somebody in Congress interested in some of the enthusiasts like Dana Rohrabacher are interested in doing something about nuclear waste. Like I said, there's money there to be had even. which makes it a very lucrative thing to go after. Back in the back there.
I think we can all be grateful that you all did this study. That's certainly progress. And we can certainly understand from where you're coming from that you've come up with a solution you came up with. But let me give you two examples, which I'm sure you already know about. Do you recall Thomas Watson of IBM saying back in the early years of, I'd say 1950 something, we think there's about a market, a worldwide market for about 5 computers? Do you recall the stories been said at other ISDCs where Glenn Douglas of Douglas Aircraft Company saw that there was a market for 15 DC-3s, and he felt that he could not make a profit until he sold 30, and that in the world as a whole was only room for 15 to be sold. But he went ahead anyway, and in the next 20 years they sold something like 70,000 of them. So I think that even though we can be appreciative of what you've done, it's almost impossible for somebody, before a leap has happened, to see all that's going to happen. If you had been given an opportunity to invest in Apple computers when they first got out of their garage, you would have probably said, oh, 50, 60, 100, computers, and of course it's revolutionized the world. So I think that you all, even though you're bottom line thinking, as you must, you also got to leapfrog the possibilities. Just because we have those other examples in front of us. And in terms of the cost of doing it, my understanding is that to develop the Delta Clipper is going to take well less than $1 billion. And if people can come with $5 to $7 billion for other things, which of course shows that there's more profit, but there's potential of profit, and there's opportunity based on historical things that there will be profit. It seems wise that somebody would say, I could put a couple $100 million now to develop the Delta Clipper technology or whatever other technology. The idea is, I know those kinds of numbers, and see where it leads. It's bound to do some good. It might show some opportunities that were not immediately apparent. So, obviously we can't persuade you, but I think it would be wise.
I couldn't agree more. It's just, would you bet your company right now on it?
Those who do make it. Those who don't do not. Based on doing some good careful thinking, not just jumping blindly, but we have the historical precedent that it does pay off.
Well, I'm going to get off the stage and let Antonio go up here because he is in effect betting his company right now. So we'll get to that later. Yes.
You said at between $2 and $3 billion becomes a factor. So you'd be completely open to a joint venture with the government. Would they put up half the money?
Hey, the government is the absolute worst partner we've ever had in the world. That's the problem. We'd do anything not to have to put up with government, but right now I don't see an alternative.
Hey, Rich, that's all the time we have. Thank you very much.